Okay, this is part 2 continued on. You guys should also, let's see, we've talked about bond strength and polarity, how that affects acid properties. We talked about oxyacids, how the presence of oxygen and how many oxygens there are affects acidity as well. And then also you should know highly charged metal ions produce acidic solutions, and that the greater the charge of the metal ion gives you greater acidity. And what I do want to do is I just want to show you guys kind of what we're talking about, what that looks like. So, for example, highly charged metal ions. Most common one of this is aluminum. With its positive 3 charge. Now, aluminum ions, when they get in water, what happens is all those little water molecules, let's see, that would be my H2O, so this would be my negative end. These are all little water molecules with the negative end over there. The negative end of the polar water molecules can come and stick to basically the positive. Those are opposite charges, so they attract one another. So this positive charge of aluminum is attracting the negative charges of the water molecules. Now, those are only partial negative charges, and so it's not like you're just going to have 3 water molecules to balance out this positive 3 charge, because this isn't a full negative charge. It's just partial. So there will be a certain number of hydrogen or water molecules that will be attracted to that and kind of connect with the aluminum ion. And when that happens, it's said that that metal ion has become hydrated. And what that looks like is, with aluminum, it just so happens that by experiment 1, 2, 3, 4, 5, 6 of the water molecules will come and stick to aluminum ions. So we have, they show it like this. We've got aluminum, and then H2O, 6 H2Os are going to come stick to it. Now still, there's a positive 3 charge there, because this isn't canceling out any charges, because it's still part of the water molecule, but it just happens to kind of stick to it. So this together is a hydrated, and we'll write that, hydrated ion. And that will dissociate, becomes acidic. And we've got, when that dissociates, basically one of those water molecules will turn into a hydrogen and a hydroxide. So I'll have H2O, but I'll have 5 of them instead of 6. And then an OH. And then 1 hydrogen ion that will break off of that, which is why it becomes acidic. And then the greater the charge of the metal ion, the greater acidity. And so again, you kind of commonly would get a question about, which one of these would you expect to be more acidic in solution, and you would just pick the one that has the greater charge. Okay, now acid-base properties of oxides. We've talked about this a little bit already with some of the reaction stuff that we have done. This is actually a good review, and maybe it'll help it make sense a little bit more. When you have a metal oxide combining with water, you get a base. So, for example, potassium oxide plus HOH, and usually I just write it this way just so we can kind of see the breakdown of the hydrogen and the hydroxide, will give me 2 KOH, potassium hydroxides. Okay, this, however, is a strong base. And so there's a little section on the AP test, there's one question, and there's 3 reactions that it asks you to write out the formula for. And you need to do net ionic equations. And so since this is a strong base, I know that it fully dissociates. And so I would have K2O, which is a solid, plus H2O, my liquid. And that's going to give me 2 potassium ions and 2 hydroxide ions. So you need to show it this way. You need to show it dissociated since it's a strong base to get full credit on that. If you just gave this answer, you wouldn't get full credit. Okay, another example. Let's see, that was example A. Example B, if I've got iron 3 oxide plus H2O, just gives me iron 3 hydroxide. Sorry, these should all be aqueous over here. Okay, this is a weak base. Okay, we know this to be not one of the strong bases that you have memorized. So since it's a weak base, when you're writing out the equations, you leave it just like that. You don't dissociate it because most of it is going to stay together. All right, nonmetal oxides, water and water, produce an acid. So let's say I've got P2O5 plus H2O. That's going to give me, and you kind of just have to look at what things you have working over here. So I've got phosphorus, I've got oxygens, and then of course my hydrogen, which is going to make it acidic. So I'll start with hydrogen over here. And since I have phosphorus and oxygen, I am going to say that that makes phosphoric acid, which is weak, so we leave it put together in the equation. We don't dissociate it because that's a weak acid. If you had, for example, sulfur trioxide plus H2O, and actually these can all be double arrows, H2O, then I'm going to get sulfuric acid. I've got SO3 plus another oxygen is SO4, so it's sulfuric acid, which is a strong acid. So if I write it out correctly, I should write SO3 plus H2O, and then the most correct way is to do it like the first step. You know how with the polyprotic acids we did it in steps, and the first step is the only one that is the strong acid. So this sulfuric acid right here is going to dissociate and be a hydrogen ion and an HSO4 minus. If you had gone through and you put like 2H and then SO4 separately, I don't think they would mark you down, but this is the most correct way to do it, is to show that it's that sulfuric acid that's the strong one, and it dissociates one hydrogen at a time. Okay, and really quickly, Lewis acid bases. Example, just real quick, you have to be able to identify, given an equation, which one is which. So Lewis acids are the electron pair acceptors. Lewis bases are the electron pair donors. So you just have to identify which one needs electrons, and it'll be the electron pair acceptor, which one has extra pairs of electrons to donate, and then that'll be the donor. For this, nickel 2 plus 6 NH3 gives me nickel and then NH3 6. If you're asked to identify which one is the Lewis acid and which one is the Lewis base, you should automatically know, and this should just be something that you get used to knowing, NH3 has an extra pair of electrons right there. So right away you can tell that that's going to have an extra pair of electrons to donate, so that's going to be the base. And since nickel has a positive charge, it can accept electrons, which would make it the Lewis acid. And I know we talked about that a little bit at the beginning, but on your homework you're expected to be able to identify those given equations.